Hi, and welcome back. So the next 4 chapters of the book covers the role of expectations in output fluctuations. So for the purpose of our course, we're only going to look at chapter 14 and 15 in terms of expectations, and we're not going to cover 16 and 17. So in this video, we kickstart chapter 14 of our macroeconomics 2 module. So chapter 14 introduces two very important concepts. So the first is the distinction between the real interest rate and the nominal interest rate. So we'll use this distinction to discuss the Fischer hypothesis. So the Fischer hypothesis is the proposition that in the medium run, nominal interest rate fully reflects inflation and money growth. The second is the concept of present discounted value, which plays a central role in the determination of asset prices and in consumption and investment decisions. So our first task is to introduce the concept of expectations. So what exactly are we talking about when we refer to expectations? So the idea is that many decisions depend not only on what is happening today, but also on the expectations of what will happen in the future. So an example of this is that an increase in sales today may cause a firm to alter its investment decision. But this decision should depend on whether the increase in sales is accompanied by expectation of continued higher sales in the future. Otherwise, this will be a bad decision. So another example that you have to think about, or another scenario that you'll have to think about is as a consumer, when you consider buying a new car, you must first ask certain questions such as, can I safely take a new car loan? Or how much of a wage raise can I expect over the next few years? Or maybe is another recession coming? How safe is my job? And so on and so forth. Also, as a manager in a business who observes an increase in current sales, you must ask is this a temporary boom that I should try to meet with existing production capacity? Or is it likely to last, in which case you should probably order new machinery? You need to consider such questions because, for instance, in the last example or scenario, the new machines may not be in operation before sales have returned back to normal. By then, they may be sitting somewhere in the storage, idling and gathering dust. So we haven't until now considered or paid attention to the role of expectations when making such decisions. So this chapter lays the groundwork and introduces us to this concept. So the first thing we need to do is to make a distinction between real and nominal interest rate. Then we'll introduce the concept of expected present discounted values. Okay, so firstly, we need to define nominal interest rate and real interest rate and see the difference between the two. The nominal interest rate is the interest rate in terms of rent. So this is the interest rate that is mostly published in news articles from month to month and so on and so forth. So if the nominal interest rate for year T is given by or represented by IT then, this would suggest that borrowing R1 this year requires you to pay 1 plus the interest rate of the rent next year. So it means that you pay the R1 that you've borrowed plus the interest rate. So if the interest rate, for instance, is 2%, it means that borrowing R1 this year would require you to pay R1 plus the 2% next year, 0.02. So it means that you would probably pay 1.02 with the interest rate. The real interest rate, on the other hand, is the interest rate expressed in terms of a basket of goods. So if we denote the real interest rate of year T by RT, then by definition, borrowing the equivalent of one basket of goods this year requires you to pay that one that you borrowed plus the the interest rate of the basket of goods next year. So the interest rate tells us how many rands we shall pay in the future in exchange for having one more rand today. So, but we don't really consume rands. When we borrow, what we really want to know is how many goods we will have to give up in the future in exchange for goods we get today. So similar to when we lend. So when we lend, what we really want to know is how many goods we'll have to give up today for an exchange or for goods we get in the future. So this distinction is very important, especially because of the existence of inflation. So inflation is important when considering future interest payments or returns, because what this means is that if the value of money changes over time, then the money that is you get in return might be either higher or lower than the money that you invested in the beginning. So for instance, if money depreciates by over 50% and your interest rate is less than 50%, it means that the return in money that you've got is basically less than before. So it's similar as borrowing somebody a 1 rand now and only getting a 90 cent next year. So this then advocates the need to make the distinction between nominal and real interest rate. So what is the relationship between nominal and real interest rate? Or rather, how do we go from nominal interest rate that we do observe to real interest rate, which is typically not really observed? The intuitive answer is that we must adjust the nominal interest rate to take into account expected inflation. So let's go through this step by step. So first, we make a few assumptions. So we assume that we live in an economy with one good. Say maybe that good is bread. We'll obviously add other goods as we go by. So denote the 1 year nominal interest rate in terms of rent by IT. So that stands for nominal interest rate in terms of rent. Such that if you borrow 1 rand this year, you will have to pay 1 plus IT or rent next year. But as I said, we are not really interested we're not interested on rents or nominal interest rate. What we really want to know is if you borrow enough to eat 1 loaf of bread this year, how much will you have to pay or repay in terms of loaf of bread next year? So for instance, if the price of the loaf of bread this year is represented by PT rent, so to eat 1 more loaf of bread, you must borrow PT rent and pay 1 plus interest rate of PT rent next year. But as I said, we are not really interested in rent. So what we want to know exactly is if you borrow enough to eat 1 more loaf of bread this year, how much will you have to pay in terms of loaf of bread next year? So figure 14.1 below helps us derive this answer. So we are going to further make some simplification, and we let P expected price of T plus 1 to be the price of bread expected next year. So how do we move from nominal interest rate to real interest rate? So this figure here, figure 14.1, helps us derive this answer. So the top part here, the top part of our figure repeats a definition of 1 year real interest rate, while the bottom part here shows us how we can derive the 1 year real interest rate from information about the 1 year nominal interest rate and price of bread. So if we start from this point here where we've got 1 good and the arrow pointing down, it basically suggests that suppose you want to eat 1 more loaf of bread this year. If the price of a loaf of bread is PT rands, as shown, to eat one loaf of bread, you must borrow that PT rand. So if the interest rate is given by IT, as we've been stating, then if you borrow that PT rands, you will have to pay 1 plus the interest rate of PT rands next year. So this is represented in this bottom part of our figure, and emphasized by that arrow moving to that point. But what we care about is not rands but loaves of bread. Therefore, the last steps involve converting rands back to loaf of breads next year. So we said we let P expected price of T plus 1 to be the price of bread you expect next year. So how much you expect to repay next year in terms of loaf of bread is represented by, or rather, is equals to this transcription here, which is basically the number of rands you have to repay next year, shown up here, divided by the price of bread in terms of rands expected next year. So this is the equation that shows us that conversion. So in essence, this basically says the real interest rate is basically the normal interest rate paid next year, adjusted for price. So how do we adjust for price? As we've shown here, is that we know that this is the real interest rate of this price, but we need to adjust for the change in price. Hence, we divide by the expected price, or the difference in prices between the two terms. So this is also shown by this curve. So we are saying 1 year real interest rate is equals to the nominal interest rate adjusted for price. So the nominal interest rate of the price that is nominal divided by the expected price. So putting together what we see in both the top part of our figure, it follows, and as well as the bottom part of the figure, it follows that the 1 year real interest rate is given by equation 14.1. So we put together information from figure 14.1 and find that real interest rate is given by equation 14.1. So this is pretty straightforward. As I said, it basically tells us that real interest rate of next year, or 1 year real interest rate, is equals to the nominal interest rate adjusted for price. So this relation looks a bit intimidating from equation 14.1. So we do two simple manipulation to make it look more friendly. So first, we're going to denote expected inflation between term T and term T plus 1 by expected inflation of T plus 1. So since bread is the only good, the expected rate of inflation is equals to the expected change in the rand price of bread between this year and next year, divided by the rand of the price of bread this year. So this is simple, as you can see here, represented by equation 14.2. Expected inflation is equals to expected price next year minus the price this year divided by the price. So this is simply the way you calculate inflation. So if you may remember, inflation is calculated that it's CPI this year minus CPI of last year divided by the CPI of last year. So we are going to continue the explanation of this relation in the next video. All right. Thank you.